Hello, hello, hello. I am here to tackle Advent of Code Day 8. Catching up a little bit. So, got some text here. It's another grid parsing doohickey. Got. Don't forget the trim. Okay, signals, letters. 14. Know what that means? So, what are we supposed to be doing again? A frequency of blah 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 blah. Okay, let's look at my input. Okay, lots of letters. Case variations. Cool, cool. Interesting. Okay. Let's see what we got. Frequency only applies specific antinodes. For those two antinodes of frequency A, they create two antinodes marked with hashtag. Then a third antinode of the same frequency creates several more antinodes. Oh, an antenna antinode. Would ideally add four, but two are off the right side of the map. Okay, so it's not an infinite universe. How do they create? Oh, is it pairs? Perfectly aligned with two antennas. Okay, so I'm gonna go TL draw. It's actually a very visual problem. Mono. Okay, so we get this one because of this line. Okay. Oh, I see. That's where they all show up from. So, let's go with this color. I forgot. Okay, sure. Let's go here to here. And then that creates another one, which technically goes off the universe, so we don't see it. But the opposite way, we do see it from there to there. Okay, so I create these hashes. Is this, do I count how many hashes there are? 14 unique locations that contain an antinode within the bounds of the map. Okay, I get it. So I have to generate all permutations or pair combinations of what's of this? Wait, this is another example. Okay, this is my example. 3A's. Are these? What are these? These are zeros. What am I doing for zeros? Are these also antinodes? Oh yeah, I can see them. Okay, so it's any character that's not a thing. Do they have to be their own? Can the zeros make thingies with zeros? Or with A's, rather? It doesn't look like it because I'm not seeing the pattern. Okay. I did see case changing. Is case insensitive? A and A count as different frequencies. Okay, so I just need to, let's start with the world. So it's data, split, new line, map into array of characters. And now I just need to find the locations of all the antennas. And then all antennas of the same character generate permutations of generate all pairs, basically. And then for all pairs, calculate hashtag locations and then just mark up the map a whole lot. Okay, we got that. So const antennas, right? Antennas equal hash map. So for let 0 are less than and fly plus plus through every row. Handle them nice rectangular universes. Okay, so basically it's if it's not a dot, right? Not equal a dot. What do we want to do? Well, we don't want to increment world. We want to increment that. That means it's antenna, so antenna equals world RC. I could have saved myself some effort there. If not antenna and antennas, then antennas antenna equals, I guess it's an array. It's an array of locations. So let's give this a type what we want it to be. Record string, and then R number C number array. Seems good enough to me. And then antennas, antenna dot push RC, and now we just have a whole bunch of antennas, async. Look at that. So with the 0, we have all 4 of the zeros and all 3 of the capital A's. Okay, good. Now we need to generate. Where did this come from? I don't know. That had to have come from somewhere. Oh, did it come from this? Okay, it came from that one. Okay, seeing the origins of these, that's confusing. Okay, so we just need to go through. So for const type in antennas, and then we could do the fancy thing or we do the lazy thing. Fancy thing is like generate all permutations or combinations or whatever the right word is, limited to a length of 2. The lazy way is just 2 nested for loops and like, hey, let's just ignore when we hit ourselves. So we're going to do that way. So for const a of antennas type, for const b of antennas type. Now, if you're on the same, you should ignore each other. Otherwise, we're going to be doing the thing. Now, this is going to result in a universe in which we do, like, for example, we do this one and this one, and then we do this one and this one. So we're going to do reverse pairs. A fancy way we can do this is to go by entries and then use some indexing. I should have done an while loop, but if the efficiency will be bad, I'll do that. Efficiency might be good. So now we need to generate the difference between them and then math to go to the next one. I guess this is const x diff equals abs a dot, okay, it's not x diff, it's r diff. A to r minus b to r const y diff equals f abs r c minus b dot c, so I can c diff. I don't think these need to be absolute though. Because that loses directionality, right? Like, okay, I know it's 1, 3, but they're not all in the positive, so I think we drop the absolutions. This might give me the wrong directions, so I might need to juggle this a bit. I need to know which one I'm dealing with, though. So I guess I need A and B. Now I can see who I'm looking at. So 1, 8, and 2, 5. Hey, which character are we looking at? Oh, they gave us other examples. I'm going to use these other examples. That really hasn't helped yet. I guess I need to make a copy of this. Oop. And I hope this image is complete in which 2 is the right answer. Oh, there might be one down here it's not showing up on. I'll work on it. Yeah, undefined, not equal to. Great. So now we can see just the 2 we're looking at. Oh, we're looking at hashtags. How do you get in there? Though you don't have those yet, you cheat. Okay, now we're looking at it. So -2, -1, 2, 1. 5, 5, 5, 3, 4. Okay, yeah, we're looking at them in reverse. It's annoying, but it should be fine. So, oh, weird sound outside. So to go from 3, 4 to 5, 3, I go -2, negative. Actually, this is perfectly what I want because it's gonna get me in the direction I want. So if I'm 3, 4, I need to know where the next one. So const. Next r equals a dot r plus r diff. Next c equals a dot c plus c diff. Now again, I'm making some executive choices here. next R, next C. Okay, so I'm saying it's 1, 3. 0, 1, 0, 1, 2, 3. Hey, and the other one is 7, 6. 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6. It's working. It's not going all the way, but I think it'll be some while looping, and until they hit the end, I can do that. It's really weird that it's working though, because I haven't caught up to the math, but sure. So now we just need to be like, hey, look, we found some things. Do I just set them on the world? Because I don't need these positions in the world anymore. What happens if a thing appears on a place that's another antenna is at? We'll just go with it. What's the worst that can happen? So, world, well, we'll have to make sure there's a chance this is off in the universe. So, if not equal undefined, gotta watch out here. Then, world, next R, next C equals, I guess, hashtag, then what? We just count up all the hashes, right? So for const row world, let, I forgot the proper name for this. For const cell of row, if cell equals hash, oh gosh, I'm pushing on the wrong button. Hash is plus, turn hashes. Okay. I don't know why this is working. Oh, it's working because I haven't done the rest of it yet. Answer's too high. Okay, okay. So, I didn't write. So I made the assumption that, oh, hey, if it's on an antenna, then we don't want to do that. Interesting. Ooh, can occur that have them. Different frequencies can occur at locations that contain antennas. The lone A creates none, but has a lowercase a at its location. Okay, so if I were to take this one as a test case, and maybe copy this bit, what would this one generate? So we have 1, 2, 3, 4, 5. Excuse me. Can occur at locations that contain antennas. A creates no antinodes, but has a lowercase a frequency antinode at its location. Right here, yeah. Why is this saying 5? Okay, I need to see the world. Show me the world. I forgot how horrible this thing looks. Oh, hey, look at those. The 3 up there. How'd you do that? That's illegal. How'd you get one way up there? You have nothing to do the thing with. Okay, let me focus on the problematic. How did you do that? Oh, okay, it was a little off by a 1, annoyingly. Okay, if we just like, hey, just do that, will I get proper output looking? No. Okay, what if there was a universe in which I saw these and they looked good. Oh, if I don't do all the joins, I just spit it out raw. Okay, there we go, it's a better shape. You have 3 of them. Who gets you up there? Are you jumping off of that hashtag? You shouldn't be. Okay, what antennas do you have? You have hashtag antennas. Dang it. Did it again. Okay, and this is supposed to be 4. What is supposed to be? It's supposed to be 4. Oh, this isn't good. I don't see what I am missing. Reading comprehension, not even once. Um, hmm. So the way I'm doing the matching, maybe I should do it in a way that I understand so that I can follow it. Um, because the topmost A overlaps with a zero frequency antinode. Zero frequency antinode. Which zero frequency antinode? This one? Yeah, this one right here. There are 14 totally unique locations that contain an antinode within the bounds of the map. Yeah, I get it. That's what I had. I have 14. Can I look at your map? Or your world, rather? Yeah, you replaced your top A with that. That's what I anticipated. This is exactly the way it matches their picture. You got the line, you got the 2 offs, you got that one, you get the 3 on the right, you got the 2 between the A and the 1 at the bottom. It's all there. What have I done wrong? 296 too high. I have to look at this freaking input, see what's going on. It's gonna be painful. I mean, it's not, it's bad, but it's not that bad. Yeah, 5 and 5. Then these 2 5s, you'll make one up there, one up there. Okay, I'm trying to think. Did I do something bad by overriding them? I didn't, because that's post calculation. It's not undefined, then go ahead and set it. Yeah, we already have all our antennas right here. It's fine that we're. No, no, Windows, no, 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 no. Ah, hate Windows. I really do sometimes. Give 247. Great, we love it. Big fan. Any grid position exactly in line. Some will occur. That means some of the new antinodes will occur at the position of each antenna, unless it's only its frequency. So these 3T, the 3T are all exactly in line with 2 antennas? No, they're not. The original example is 34. Okay. I think it's just telling me to keep extending. So there was a while loop. So the part I was worried about I hadn't finished yet was actually part 2. That's nice. Drop that. Drop that. Let's kill that. All this over. Except for that. I think it's just need to shove a while loop in my double nested to make it go more. So while false, let's not break the computer just yet. Did I put okay, I did put solve 2. So while not equal undefined, and I need to swap these to let's. Then I need to do the thing and then increment them by the difference. So don't need that conditional there. That is the thing I need doing. Incrementing by the difference are these 2 lines here. Instead of let, it's do this plus equal those. Yeah. Again, I'm still doing double the math, but it's not hurting anything. Yeah, next R, next C, they're going forward, or they're going in a direction. Okay, I think this is good. Why is it not happy? Well, I don't have an input. The original example has 34 antinodes. I need the original example. Gimme, gimme, gimme. 29 not equal 34. Oh no. So this isn't doing its job. While it's not equal to undefined, keep going. Why aren't you going? I got my character turn replaced. 29 not equal 34. So you do have more, but you don't have all. Okay, what are they? Let me reread it again. Any grid position exactly in line with at least two antinodes of the same frequency, regardless of distance. Positions of each antinode. Okay, let me look at this one. Build my way up. Well, they gave you 7 different examples. Okay, put that there. So what? 1, 2, 3, 4, 5, 6, 12. Oh, and the total number is 9. Okay, so I am wrong. The code is wrong. I'm all wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9. How did that happen? Antinode occurs on any grid with at least 2 antennae of the same frequency regardless of distance. The 3 T frequency antennae are all exactly in line with 2 antennas. The 3 are in line with 2. Where? You're in line with your own antinodes. What, do I just plus the number of things I find? That does feel right. I'm 29, 30, 31, 32, 33, 34, 35, 36. Okay, yeah, that's not the solution. Hello? Okay, let's see. What antennas do I have? I have T and I have hashes. Dang nabbit. I did it again. Okay, now 6 is not equal to 9. Oh, hey, look, it's another one way up here. Okay, 6 is not equal to 9. You get down here. You get down there too while you're at it. So top left, 6 not equal to 9. So those are all the ones I imagined. I'm not seeing what it's saying though. Any grid position exactly in line with at least 2 antennae of the same frequency, regardless of distance. New antinodes will be added at the position of each antenna. Oh, occur at the position of each some new. Okay, sure. So if you're doing an A and a B, as soon as you got an A and a B, you both. Okay, fine. I can do that. World A.R. A.C equals hashtag, and I'll do the same thing for B. But I thought I counted it in the example, and it didn't work. No, it was me again. I was messing up. And there we go. Reading, not even once. Whew. Got it though. Okay. Now let's commit that. And honestly, it's not going to be a lot to clean up here. Do not get rid of that file. It's an important file. Go. Not there. Add day 8 solution. There we go. Okay. Let's see what they actually wanted us to do. So, what they want here is, like, did explain it into multiple different steps of when you find a character that's not a dot on this map, they are considered antennas. And the character they represent determines their frequency. So these 3 antennas are on the same frequency, And these 4 antennas, all these zeros, are on a different frequency. Any 2 antennas on a pair can be combined and can create an antinode, which is just, in our cases, a hashtag mark, at where the next antenna would be if following the same distance between them. This is like so if this is a line, we create a line here in like infinity. The distance between the 2 antennas added to either of them in the opposite direction, following the same slope or whatever, create a antinode at that position in both directions. And you do that for every pair of antennas. Now, sometimes this can result in an antinode being at the position of an arbitrary antenna. That's completely valid. They're saying it with these 2 here. We're creating an antinode going north, and we're creating an antinode going south, but it's not visually representable because we only have 1 character here. But underneath this capital A antenna, there's an antinode here there. And it is case sensitive. So these these lowercase a antennas are not the same frequency as the capital A antenna. And that's it. That was it for part 1. Map those out and count how many there are in the map. Part 2 is a double. Well, it's got 2 things. One, every antenna now also has an antinode just at its position by default for free. Secondly, the line that I mentioned, the imaginary line, you don't go just 1 distance between your pair out. You go as many distances between your pair out until you exit the universe or you go off the grid. So usually you just go to here if it was part 1, but part 2 says now you keep going and going, and you just went off the grid, so you stop going. And that's all part 2 really was. So a pretty good one. Yeah, I like the intermediate examples. They really helped me follow it along. And yeah, as for how my code does the trick, thankfully, I really wish I did have the energy day of, because it would have been really good, but it's okay. So the way the code does go through it is first we turn our world into an array of strings. We get rid of carriage returns because we love windows. And then we create a mapping of antenna frequencies, so that's the key, to an array of antenna coordinates, row and columns. And when this is done, it looks like this. We have where all the A's, then you have, hey, look, here are the coordinates of every lowercase a. And then we're getting console logs from other ones, but hey, look, here's where all the lowercase a's, here's all the uppercase a's. Same for all these. And this works by looking for any character that's not a dot, which means it's an antenna. Grab the antenna, and we're not going to refactor yet. It says, hey, if we haven't seen this one, let's make sure to create an empty array for it. And then we add wherever we are to that empty array. Finally, for all the antennas, we go through all the types, and then for all A, B pairings of that type, instead of doing permutations or combinations or whatever, we just do a double for loop. It's equivalent data processing wise, except it does give us doubles, which we ignore. We generate the difference between them, Manhattan distance or something of that degree. We add that to our current position to get the next one across this imaginary line slope. We check that position, make sure it's still in the universe. If it is, we mark it as an antinode. Finally, we go through the universe and we count up all the antinodes. That's really it. Part 2, honestly, same deal. The only and literally only difference is that, hey, you're going to keep trying to add more and more antinodes. So instead of there being one next row and next column, we start with one and we say as long as the one you're looking at is still in the universe, make it an antinode and continue along like this the slope of your imaginary line or whatever. And that's literally the difference between one and two. So yeah, with that, I'm actually going straight to the refactor. I don't even think I really need to say much about this. It's going to look very similar. Data string. Now the trick is basically, oh, where is it? The while loop. This is the part that's going to be conditionalized to some degree. Ah, there we go. I don't know how I want to represent this. Um, okay, what I'm gonna do is I'm gonna turn this into a for loop and make it based on something like a signal power. So in my tiny refactor that makes logical sense in my mind, these antennas have a power. Like if they have a power of one, they can go out one. If they have a power of two, they can go out two. If they have a power of infinity, well, they can go out infinity. That's how I'm gonna do it. As opposed to some gross Boolean, as I prefer something at least that's more logical. Power number. And the for loop is just gonna be, hey, we're gonna keep going. For let p equals 0, p less than 10 at power, p plus, I guess. We technically have two conditionals. Both of these got to be good, or else everything's chaos. And yeah, 10 at power might be off by 1 or something. We'll figure that out when we actually use this. So let's call this on this one, return solve data. Then antenna power of 1. How's that do? It does well. Love it. And then for the other one, I'm just going to call it with infinity or max int or something to that degree. Oops, I grabbed that in my clipboard. Okay, we're not that. I goofed it up. Oh, it's also counting at its current position. I forgot that's the other bit. Yeah, you're supposed to do that. Oh, that Boolean would have been nice now. Okay, I found my Boolean. Antinode antennas. It's gross. It's fine. I think I'll just do the A, right? Because that'll A dot R A dot C equals. So it'll work when it comes back around. The A is the other one. So this one false, not F false. And this one true. There we are going. 861? 861. I'm loving it. Yeah, honestly, this is basically how I perfectly want to break it up. Maybe I can do some better things here. No, I like that. I like my loop. It's a little weird up here, but it suffices. Yeah, honestly, this is pretty clean in my book. So yeah, it's not going to be much of a walkthrough for this, but I'll go through it nonetheless. So we call our super solve function with an antenna power of 1 and a false for antinode at antennas. It goes through the world, collects all the antennas. If there are anti-node antennas. It sets one at the A position. For however many antenna power there are, it will continue to try to go out that many, either stopping when there's no more power left, or stopping when we've run out of universe to put antinodes in. Then we come back and we count up all of the antinodes we've placed. So I'll give that a better name. Antinode count. There we go. Row cell. Yeah, that's a good name. Thinking if I want to destructure these, but honestly, it's perfectly fine with me. Yeah, this is as clean as I'm willing to make it, honestly. I liked it a lot. Optimize the day 8. End it. And yeah, that was a pretty fun one. Just looking at this, yeah, easily visualizable for sure. Wouldn't see it as a fun game off the top of my head, but I will continue to think on that. But until next time, I will see you next time. Always a pleasure.